This conference will now be recorded.
Hey, good morning. Can you all hear me?
Yes, yes.
Yeah,
Yeah,
yes,
good morning. Yes, I can.
And hopefully also see my screen.
yes.
Yeah, we can see.
Yes, I can.
Okay. All right. We'll just get started in a couple of minutes. Sorry for my heavy voice today. I have a slight throat infection.
Yeah.
Okay, I still see people joining, so let's wait for maybe 1 or 2 more minutes. Okay, let's get started. Very good morning and Thank you for joining on a Sunday morning, that too on a long weekend. Hello, can you all hear me?
Yeah, we can hear you.
Yes.
Yes,
Yes.
yes,
Okay, okay,
Yes,
thank
we
you.
can.
All right. Yeah, thank you so much for joining, and let's get started. Maybe okay. Before we start, ground rules. If you're not talking, please keep yourself on mute, and you could definitely ask me any questions at any time. But just let me complete the sentence, and yeah, you can interrupt me definitely. Just yeah, you need not wait till the end if you have any questions. But hopefully, most of your questions will be answered through the demo. All right. Okay. So here's about me. My name is Kiran. I have about 13 years of experience in IT. Yeah. So primarily, I worked on both on-premise and public cloud at multiple enterprises, multiple companies. Yeah. So what do I mean by on-premise? What is public cloud? If you don't know, you will come to know in the course, okay, or in the first few days of the course itself. So I would say, I have some expertise in container orchestration, which I mean, again, Kubernetes primarily. I worked on both Azure and AWS. Okay, so I am a certified Azure Solutions Architect and also a certified Kubernetes administrator. I have worked for both MNCs and startups, so I've seen different kinds of the what you could say the way work is organized, all right, or how the way work is done in both large companies as well as startups. Yeah. Yeah, I'm not trying to blow my own trumpet, but giving you a context. um, and also I have taken about I think more than 25 batches of training over the last 4 years. Okay. Yeah, I'm coming back after a little pause. Yeah. um, so that's about me. All right, now let's get started into the actual thing. Okay, at the onset itself, I want to tell you what we are going to, or what we are all going to learn in this course. Okay, so we will understand the concepts of software development lifecycle and IT operations, information technology operations. Okay, understand various elements of IT infrastructure from the networking side, compute and storage side. Okay, we will understand the concepts of cloud and DevOps. Okay, so here we are focusing obviously on Microsoft Cloud, and we are going to do a lots of hands-on, meaning real-time exercises. Okay, when I say real-time, not like a real-time uh, production environment, but yeah, almost, because in today's world it's very easy to do whatever you are going to do in a real company. All right, so we are going to get our hands on, I mean hands dirty with all the DevOps tools. I mean, Linux is not a DevOps tool, but it's an operating system. We are going to learn Linux. We are going to learn Terraform, Git, Docker, Kubernetes. Okay, at a very, very high level, apart from Azure, these are all you're going to learn. All right. So most of the other concepts will come in Azure. And obviously, we are going to do task-based learning, meaning we are not going to go through PowerPoints only, or we are not going to talk theoretical sense only. It's going to be live. I'm going to do the stuff online, and you're going to see them. And I will also give you tasks like every couple of days or sometimes every day to do this, that. Okay, today I want you to create a Terraform module, or I want you to create a Docker file. I want you to create Azure VMs, or
yeah. Sorry for interrupting you.
yeah,
Yeah, could
yeah,
you,
go on,
it's
please.
better to add the Jenkins also.
Yeah, so I did not put Jenkins here because we are going with GitHub Actions, which is part of our CI/CD. Yeah, maybe I should have added that. We are not doing Jenkins. Maybe I will take an extra session on Jenkins. The reason being, if you go to any job description these days, it's very rare to find Jenkins. You'll find something like GitHub Actions. Okay. Yeah, I should have put GitHub Actions here, but anyway, yeah.
Okay, thanks.
Okay. So what is if you're new to this terminology, please don't be worried. Okay. We will cover all those things from the beginning itself. Okay. I mean, when I say beginning, from the very basics. So yes, we are not going to cover Jenkins in depth. Maybe I'll show you how Jenkins looks like, but our area of or rather we're going to learn a very modern tool which is GitHub Actions. Everyone is talking about that. Okay, so you will learn about GitHub Actions. Don't worry about that. And also I will give you a insight into a tool called as Azure DevOps. If you have seen my slide, the choice of words I used is DevOps with Azure, not Azure DevOps, because thanks to Microsoft, there is always some confusion because we are going to learn Azure as a cloud. What happened to my system? Azure. Okay, we're going to learn Microsoft Azure. Interesting. Why is this font like this? Okay, but there is another tool called as Azure DevOps, which is again a Microsoft tool. But this is primarily used, like as someone has asked just now, why don't we discuss Jenkins? Like Jenkins, we have Azure DevOps from Microsoft. Okay, so Azure DevOps is another tool. So that's why I'm using the term. Our course is not only about Azure DevOps. We are talking a lot about other DevOps tools. Okay, that's why I use the term DevOps with Azure and not Azure DevOps. Okay, there's a slight difference. Yeah, again, that's again Microsoft's contribution to confusing people. Um, Okay, so but we are focusing on Microsoft Azure Public Cloud, and we will focus on DevOps tools. We'll also get an understanding of Azure DevOps. Uh, why not deep dive into Azure? Hold on, sorry. I think I need to. Hmm, what editor do I have here? Anyway, so we have yeah. So I talked about GitHub Actions, right? So if you have, I'm not sure if you're following any technical news or not. If you have followed GitHub is a very popular source code repository or where people put in their code. So GitHub Actions is a tool that does the same thing as Jenkins plus more. It has even more features than Jenkins. Jenkins is definitely the best. I mean, so far it has been very strong CI/CD tool, but GitHub Actions is replacing many of these things. Earlier it was Azure DevOps. Now, since GitHub is also acquired, GitHub as a company is also acquired by Microsoft. Okay, so GitHub Actions is what is in demand, and Microsoft is also putting a lot of um, investment into GitHub Actions rather than Azure DevOps. So we are going to see how Azure DevOps looks like, but we are going to focus on GitHub Actions. All right. Again, if you don't know any of these terminology or if you haven't heard of them, that's fine. Okay. We are going to discuss from the beginning in the course. All right. So primarily, that's what I wanted to tell about from the onset itself. So it's going to be task-based learning with assessments. When I say assessments, I'm going to give you some quizzes, random quizzes. Uh, like I'll give you a set of 10, 15 questions and you have to answer them. Sometimes I give you the tasks you have to complete and show it to me, whoever has done. Okay. And again, I'm telling you from my experience, many people don't do that, but I would, you know, because you're starting it afresh, I would say, you know, those who are going to join, please complete those tasks. All right. So now what we are going to do is we're going to talk about some of the concepts that I've talked about in what we're going to discuss, like cloud and all that stuff. All right. So first, let's talk about cloud. Okay. But before that, anyone has any questions regarding my profile or the course content or anything else?
Hi, Kiran. This is
Hi,
Devendra.
Do
sorry for
we get
interrupting.
recording sessions?
Yeah, all the sessions are recorded. Yes.
So you are providing
So,
for us?
Yes, yes. They will be provided to you. They will be shared to you. You
Like
can
after
watch.
completion of the everyday session.
Yes, yes. Mostly the same day you will get the recording shared via Google Drive, so that should not be a problem.
Okay, thank
Yeah,
you.
but I would still encourage everyone to, join the uh, live classes so that you can ask questions and, it would be more
Yeah,
interesting.
yeah, definitely.
I know there will be some days where you might not be able to join, but yes, recordings will be provided. Okay, someone has some other
hey, Kiran,
question. Hmm.
yeah, do we need development skills to learn this Azure DevOps course?
I'll come to that. I'll come to that. I
Okay.
know.
How many days is this course for?
Um, See, I generally don't have a hard limit. From my experience, I would say it would take anywhere between 10 to 12 weeks. Okay, I would, s- I used to say it's 2 months course, but from my experience, I know it would take about 10 weeks. Because there will be some holidays. Maybe I'll take a few breaks here and there, whatever reasons. But yeah, within 10 weeks we should complete. So you can say uh, 10 into 5 days, because we are going to do Monday through Friday. Okay. So 10 into 5, 50 sessions at least. Okay. Sometimes we'll go up to 55, 60 sessions. And then yeah, maybe one or two additional sessions to cover whatever additional topics we want to talk. So yeah, that's how it goes. Because my primary goal would be to, I have a standard curriculum. I'll show you what all we are going to discuss, but I'm also going to focus on how we are going in the course, and if there is anything required to be explained a lot. I don't really hesitate to do that. It's not like, okay, today I have to complete this, so I will complete this. If we are stuck with only 20, I mean, if we are done with only 20% of that part, though I plan to do, let's say, 40% of that, I'm still fine. It's about how we are learning. So yeah, roughly 12 weeks is what I can say. 10 to 12 weeks. Yeah. Okay. Any other question? All right. Then let's get started. Okay. So cloud. So let me ask you this. When you hear this term cloud these days, okay, back in the day, maybe 10 years ago, cloud meant different, only one thing, but now it means different things. So what what comes into your mind when you hear the term cloud?
Serverless. For us,
Hmm.
it is
Okay.
serverless.
Cloud is
Okay.
a data storage area.
Data
There is a
storage.
different types of there is a different types of storage in cloud,
Okay.
like
Different types.
Drive HQ, AWS.
Okay. Okay.
An infrastructure as a service. If you need a
Infrastructure as a
internet, just you can log in and do all the stuff without any
okay.
storage, hardware.
Infrastructure as a service. Good. Mm, Where's my okay? This is much better. Okay. So we heard the terms like why am I not able to increase the font size? Just a second. Okay. We heard different terms like you know infrastructure as a service. Someone said storage. Someone said serverless. Okay. Right. You're all partially right. Okay. Um, So, before I explain further, let me give you what does Wikipedia say about cloud computing. So, cloud computing, that's the full term. We shorten it as cloud. Okay. Cloud computing is the on-demand availability of computing resources without the direct active management by the user. Cloud is a collection of data centers managed by a cloud provider, and users can rent resources on a pay as you use model without the upfront cost. So notice these terms: direct active management, without the direct active management by the user, pay as you use, upfront cost. Okay, and on demand availability. Right. So I'll give you a little bit of context here. So in uh, for any application to run, for example, we are using an application to connect with each other, web-based application called as GoToMeeting, right? GoToMeeting, we are using this. So our session, I'm talking to you, but are you listening to my voice directly from my laptop to your laptop? No, right? So I connected to. GoToMeeting on my laptop, right? And it goes to what we call as servers or GoToMeeting servers. Okay, I'll just call it as GoTo instead of GoToMeeting completely. It connects to GoTo servers, and you are also connected to GoTo app. Okay, so my voice goes into these GoTo servers, and from there, based on whatever settings Career IT has set up, can it allow everyone with the link, or can it allow only with those people who have username and password, whatever authentication mechanism? So you're listening to me from GoTo servers, right? So what is a server? A server is a so we talked about this term also, computing resource. So what does a computing resource mean? Computing resource means it could be a computer. Server is nothing but a computer, guys, nothing else, right? A server is nothing but a computer, a specialized type of hardware. Okay. Servers have servers. We have network, right? Network, the cabling and the routes and everything. And then we have storage, right? There could be temporary storage, there could be permanent, persistent or permanent storage as well. Okay. Um, so earlier, how organizations used to work is they would, let's say, I want to start a company called as, let's say, Flipkart, right? So then it's a e-retail or e-tail or whatever you call it. So you're selling products online, or you're aggregating products from different sellers and showing it on your website. So what do you need for that to start your online business? To start a e-retail shop like Flipkart, what do you need in the beginning? Forget about cloud and everything. Okay, so your application should be installed on some servers, some computers, right? Right? Okay, so you build an application using any language. For example, um, let's say any programming languages. Anyone wants to talk? Give me some hints. What are some of the programming languages?
Java, .NET,
Java, .NET.
C++.
These are like you know very prominent and widely used. Not .NET, Java still. We have JavaScript. We have Golang. We have Python, the good old Python. We have what else? C Sharp, C++, mm, C itself, but people rarely develop web applications on C. Okay, so any of these applications are they develop you know um, the actual application. First, everyone tests their application on their laptop itself. They write the code and they check in their own browser if the application is working, but they cannot keep running their application from their own laptop, right? They need to put it in a centralized server which can run 24 hours, 365 days, correct? These days, you know, everything runs 365 days, 24 hours, right? Flipkart, Amazon, WhatsApp, whatever it is. Okay, so you cannot do this on your laptop. So you put it on. You take the same code and put on some computers, and these computers are specialized computers, specialized hardware manufactured by companies like Dell or HP, which can run 24 hours and 365 days continuously, and also take very high loads. Okay, then you need all the network cables to connect these things, right? You need routers, you need switches, you need hubs. These are various networking concepts. Okay, so you need a lot of networking devices as well. Of course, um, you need a lot of storage. So you will have retailers giving you details about, okay, we have hundreds of these products. Here are my pictures. Here are my pricing details. Here are the discounts I can offer. So in order to show it to your end audience, okay, end users, you need to store them somewhere. So you store it where? Where is data generally stored? In your laptops or in your phones. Where is the data stored? On your hard
Hard
drives, right? Hard disks. So we have SSD disks, HDD disks, different kinds of disks. So that's what we call as storage. So this is basically what you need to start any um, online application, or any internet based application: computers, networking devices, and storage. So in short, we call it as compute, network, and storage. Okay. So earlier, before the advent of cloud, let's say a company like Flipkart has to start its business, it has to buy all these things. Let's say it estimates its traffic to be, let's say, 1,000 users per day, 1,000 users overall per day, and concurrent users of, let's say, 50 concurrent users. Concurrent users meaning the users who are logging at the same time at any given point. I'm talking about Flipkart before 2010 maybe. Okay. um, so in the beginning days, so what they need to understand is, okay, for 50 concurrent users, meaning if 50 users are accessing my application at the same time, okay, let's say the time right now in my time zone is 5 o'clock. So everyone should be, let's say at this time 50 users are simultaneously accessing my application. How many servers do I need? Maybe I need 4 servers, okay, and 4 database servers, right? Again, if you don't understand these terminologies, that's fine. We're going to talk about them later. 4 web servers, 4 database servers, and let's say some caching servers. Okay, um, a load balancer, right? So even before Flipkart started its business, it has to invest in all these things. And obviously, these things cannot be put in a simple, any kind of office room. You need some kind of cooling because these are running 24/7. I mean, 24 hours, 7 days a week. So they need some kind of cooling. Okay, they need some kind of cooling. They need multiple power sources, right? If you go to a movie theater in a mall, it doesn't only rely on your public, what do you call, electricity connection. They have their own generators, right, as a power backup. They have their own generators, or some people invest in solar. So you need power backup, power, or multiple sources of power, right? So is the case with internet. You need network connection, so you have to have multiple ISPs, internet service providers. It could be Airtel, Geo, Tata. Okay, yeah, Tata still offers fiber for large companies. Okay, or BSNL. It could be any of these companies which offer you this ISP. So you need to have more than one internet, because let's say you have Airtel connection, but due to whatever reasons, Airtel broadband, due to whatever reasons, Airtel might go down, because we all know that things always fail for whatever reasons. Okay, in your home, you might not you might not notice these days, but there might be few failures now and then you have to call the Airtel service and say, or Geo, or whatever service you're using, and tell them, okay, my internet is not working. They will repair that. But when you're running a website, you can't afford to wait for the downtime. In the meanwhile, you will switch to something like Geo or Tata or BSNL, whatever it is. Okay, so you need to have multiple ISP connections, multiple power supply. Okay, so all these things you have to put, and you don't even know your business will be a hit or a miss. Correct? So this is what we call as upfront cost. Even before your application is online, you are investing lakhs of rupees on all these things. Okay, upfront cost. And then let's say your business, first you started by some online advertising, and think about 2010. Okay, we are not talking about 2023. Flipkart started around maybe 2012 or 2013, I don't remember, but yeah, think about that time when Instagram marketing was not so popular. Everyone did not have WhatsApp, everyone did not have smartphones. So you're thinking about that time, and you're investing some lakhs of money. Okay, and what if it fails, right? These things are not easily, again, uh, sold back and getting your liquid cash, right? So and let's say whatever marketing techniques you used, you initially get some expected users. Let's say you expected 1,000 users per day, but 900 users are coming per day. Okay, but your computers are not performing very well. Users are complaining, or at least, if you have observed, you notice that there is a visible lag when more than 40 concurrent users are logging at the same time. Okay, 40 concurrent users are logging at the same time. When let's say, if the load is 40 users at the same time, your application is getting really, really slow. Okay, then what you need to do, you maybe you have to fix your code. That's one part. But in the meanwhile, you think, before you fix the code, you'll increase some capacity, meaning from 4 web servers you'll make it as 6 web servers. Okay, from 2 caching servers, maybe you'll make 4 caching servers. That means you have to buy additional hardware, right? That means again investing more money without even reaching your original target. All right, you're spending more money. So that means it will also take time. you have to order these from Dell or HP, these servers, right? These machines you have to order from Dell or HP or any other company or IBM. So while they are delivered to you, there will be some delay, and your users might be experiencing slowness. So they will say, enough of it. We will never go to Flipkart because it's always slow. Maybe he's logged in only once or twice in a day, but whenever he's logging, he's seeing very slow responses. Then he thinks, okay, enough with Flipkart. I'm never going to do it. Maybe I'll use Snapdeal, which was a popular site back then, or eBay, or whatever it is. So they're losing business, right? That means we don't have the on-demand availability. On-demand availability meaning you require it today or now, you get it now. That's on-demand availability. That is not there in. So this kind of setup is called as your on-premise setup, on-premise infrastructure, meaning you're running your own data center. On-demand availability is not there. Upfront costs are there. Okay, and also it's not pay as you go. Maybe uh, pay as you go. What is pay as you go? So let's say I talked about the concurrent users, right? 40 concurrent users may be your peak traffic, meaning at evenings mostly at some point in time 40 concurrent users are logging. But other times maybe your traffic is, let's say, um, 20 users only. That means you have 6 web servers, but all of their utilization is maybe only 10% of utilization, or 20% of utilization. At 40 concurrent users, it is going to 90% of utilization. But at 20 users, the CPU and RAM are hardly used. It's very less utilization. That means you're paying more for this all the time because you have to run them. Remember, you need to run the power, you need to run the ISP, you need to run the data center. Data center is nothing but the place where you are going to host all these things, where you're going to put all these things. So that means you're going to pay for this. Even if your users are 20 users or 2 users logging at that particular time, okay, not the total users, but at that time if the users are only 2 users or 1 users, you're still paying for the entire infrastructure you paid, including the power and everything. Okay, so the pay as you go option is also not there. Okay, and also billing, you don't know whether you're getting your returns on investments with this kind of fixed. Monthly you're spending so much money on these EMIs, maybe on the power bill, ISP bill, your data center employees, because you have to employ some people to take care of all these things, right? So that's another cost. Don't forget that. Data center personnel. Okay, including security. You need to have physical security, meaning security guards outside your data center protecting your systems, right? So all these things are actually cost, directly cost, okay, upfront cost. That is before cloud. Now talk about, you know mm, cloud has really started picking up from 2009-10 also. But this is not how Flipkart has started its business, guys. um, Flipkart has not started its business with its own infrastructure. Okay, it did not buy even one server. Flipkart started its business on AWS. So it it's create the founders of Flipkart created a subscription on AWS, Azure, Amazon Web Services, and they started building their servers on AWS. So now we are coming to what cloud actually means. Now, so for any online business, any online application, you need to have all these resources, but you need not buy them. In this era of public cloud, you don't have to buy anything at all. Okay, so you can go to AWS, create an account. Maybe they will give you some free credits also initially, that okay, you can use up to these many machines for free. So they created their servers on AWS. They started uploading their code onto AWS. They started running them, and AWS gives you all these options of no upfront costs. Meaning, let's say the same setup they did on AWS. Okay, so this thing is gone. You don't have to maintain power. You don't have to maintain data center people, because everything is maintained by AWS. AWS has its own data centers. You can log into a website and require how many web servers you need, AWS or Azure, anything. Okay, so AWS, Azure, Google Cloud, or Oracle Cloud, doesn't matter. Any cloud, they maintain their own data centers. That means all these things are already gone from your cost. You don't have to maintain for power, anything. Okay, and right. So let's say Azure itself. So they go to Microsoft Azure portal, they log in, they create an account, they give their credit card details, okay, and they start using these 6 web servers, 4 database servers, 4 caching servers, and a load balancer. But they won't, of course, maybe some hard disks, okay. Here I did not include hard disks because most of the web servers come with their own storage. Let's say they are using 5 terabyte of storage also. So here you're not going to pay a single rupee to start your business. Just you need to have a credit card to sign up, and you can have all these resources. You will pay the bill at the end of the month. That's fine. You don't have to. So that means you know how your business is doing before you're spending any money. Okay. And let's say after a few days, we talked about this, right? 50 concurrent users, but let's say it is doing much better. It's going to 75 concurrent users, meaning you need more resources to support your users. More users are coming simultaneously. So then let's say you need to increase your storage, you increase your capacities from 6 web servers. Let's say you go to 8 web servers, okay, 6 DB servers, and yeah, caching servers might be good. Load balancer is same. Storage maybe 5 TB for the time being. Okay, but cloud also gives you another wonderful feature called as elasticity. What does that mean? So you have noticed that your traffic during the day is anywhere between 25 to 100 users, concurrent users. Concurrent users, again, you understood the term, right? Concurrent users, what it means? Hello?
Yes, the users log in at same time.
Same time, right? Yeah, not the total number of users. uh, I mean, today Flipkart might have thousands of concurrent users. Even 10,000s also is not a exaggeration. But let's say during the night, the concurrent users might be just 5 to 20. Okay, so you notice this trend, and now because of this elasticity, what you can do is during the day you can put your servers at this capacity, but you can say in the night I want to turn off these 4 web servers, and let's say I want to run only 3 DB servers. I want to run only 2 caching servers. Okay, load balancer you should have. Storage you cannot change much. So now, since cloud offers you this pay as you go, the way your billing will operate is for this for during the daytime. Let's say each web server cost is €1 or $1. Okay, $1. Same with the, I mean, again, web server and DB server are nothing but they are computers only. Based on what software you're running, they will, let's say this is $1.5 because you're using high capacity. Caching server maybe, um, let's say, it costs you around $1 again. For storage, again, we'll not talk about storage right now. So during the daytime, you're spending 8 into $1 into, let's say, 12 hours. Okay? And during the night, so yeah, here also 8 into 1.5 into 12. I mean, I dividing the day and night equally. So 8 into, uh, again, $1 into 12 hours. This is what you're paying during the daytime. But in the night time, because you're running at a reduced capacity, okay, you will pay only this much. Again, these are like sample numbers. Don't think like this could be fixed. Okay, uh, yeah, here it is 4. Okay, so now your billing is different for day and night. Of course, you'll get the entire total bill at the end of the month, right? So you can save during the night. You're turning off these machines, and you're saving on your billing. Your billing is coming down. Okay, and today we have, not today, I mean, it's been there from many years. There is something called as auto scaling. Auto scaling means without manual intervention, your servers can increase or decrease. Okay, of course, you have to do the initial configuration. That's the job of your DevOps and cloud engineers responsibility. So what does this auto scaling means? Let's say, again, we'll discuss this in detail in the context of Azure, but just to tell you why cloud is so powerful is this auto scaling feature. Let's say, mm, at 9:45 India time or 8:45 India time, mm, your load is um, 50 concurrent users. I'll just call it as CU. So now let's say you need um, 4 servers. I'm saying 4 servers, but again, let's say each server has 2 CPUs and 4 GB of RAM. Okay. So whatever reasons you're running your promotion, your traffic has gone to 50 concurrent users. Then cloud has the capacity to automatically scale up the capacity. Okay, from 4 servers, it will increase to 8 servers. Again, with the same capacity, of course. Um, each server has this capacity. Okay, so because this is automatically done through auto scaling based on the user load, so you don't have to sit in and turn off some servers and add new servers. Your cloud will be able to add the same kind of servers but more in number. In this way, the load is automatically managed by your cloud. Okay, that means, and again, let's say after some time, your load has come down to 40 users or 30 users, 30 concurrent users. In that case, the cloud also has the capacity to scale down or decrease your capacity. So it has the capacity to, I mean, you can define these numbers, how much it has to increase and how much it has to decrease. Okay, so it can decrease into it can, based on your specifications, maybe it can decrease to 3 servers. Okay, and these days, I talked about hourly billing, right? 8 into 12 is 8 servers, $1 for each server for 1 hour, but 12 hours. But these days we have something called as per second billing. AWS introduced that. I think Azure also has per second billing for many of the resources. We'll talk about that later. So per second billing means if you used a server for, let's say, 1 hour, 45 minutes, 36 seconds, you will be billed only for these 36 seconds. You will not be billed for the remaining 24 seconds within that minute also. Okay, we have per second billing. So um, per second, how many servers are you using, you will be billed only for that. Okay, so that's the power of cloud. That's what I meant by pay as you go, right? Pay as you go. And billing, it gives you complete overview at the end of the month. I'm not sure if any of you have used a postpaid biller, still using postpaid phones. We use, I mean, prepaid is much easier now anyways, right? So in your postpaid bill, if you have ever checked, it gives you every detail, like which phone number you have spoken to, how many minutes, and how much did it cost you, or which phone numbers you have sent SMS. So how much is the billing? How much data you used? Everything is shown right in your itemized bill for your postpaid connection, right? So similarly, in cloud also, it gives you very detailed billing. It tells you that okay, you used this server with this capacity. Okay, you used this load balancer with this capacity. You used so many hard drives, each of them with this capacity. Okay, you used for these many hours in this month, so your billing is so much. Again, we'll see all this in action, right? How the billing works and everything. Because from the beginning itself, we should be worried about our billing. Yeah, I mean, you will not pay. You'll all subscribe to Azure free tier, but these are all the things that cloud offers. No upfront cost, on-demand availability, pay as you go, elasticity, auto scaling. Elasticity in the sense the ability to scale up or scale down. Scale up means increase your number of resources. Scale down means decrease your number of resources because there are not many people accessing your applications. Of course, you will still have all the storage in a separate location. So even if you're scaling down, nothing is lost. That's how you need to configure those systems. Anyway, right? Okay, I think I have spoken a lot. Any questions? Anything you want me to elaborate here? All good?
You were asking regarding this cloud
Yeah, yeah.
or any other.
Whatever we talked so far. Yeah. Any
Can you please
questions?
show me the course content once?
I will go to that. I don't want to jump topics now. We'll go to the course content.
Okay.
Okay. Um, So, um, yeah, that's about the cloud. So, a real life example I would always give everyone is uh, think about a physical business, meaning, let's say you're starting your own garment shops, your own clothes store. Okay. um, so then what do you need to start a uh, offline clothes store? You will need a, you know, showroom, right, to display all your clothes that you're selling. And of course, you'll need a storage, right? So this is your store, or whatever you call, yeah. And this is your warehouse. Warehouse is nothing but, where you store your, because once these items are done, you will pick up from the warehouse, or some people might require a different size which might be there in warehouse. Okay. So let's say you have rented a store of, let's say, 50 square yards, right? And the warehouse is of 100 square yards. Okay. Initially, this is enough for you. You're getting, let's say, at any time, at any given time, the concurrent people or footsteps that you're receiving is, let's say, 10 people at any given time. Sometimes it might be 11 people, sometimes it might be 8 people, but on an average, let's say 10 people. But let's say if your number of concurrent visitors is increasing, imagine if you have the capacity to automatically increase your showroom size, right? And also, if your load is increasing, if the number of users are increasing, visitors or what do you call, customers are increasing, then obviously you have to have the more number of stock also. Let's say if you have the ability to increase automatically, how wonderful it would be, right? That cannot happen in real world, obviously. You cannot make your showroom from 50 square yards to 75 square yards automatically, because there are more number of people coming. But imagine an online business, the same thing will happen. Okay, maybe this is your front end, this is your back end, or your data storage. You can expand them as if there is infinite space, as if there is unlimited space. You can expand, and you can also scale down. Let's say, post lunch, afternoon, let's say you have very less number of visitors. Let's say you can only decrease it to 10 square yards and pay only for 10 square yards for those 3 hours. How wonderful it would be, right? But that's not possible. But that's not possible for physical infrastructure, but for cloud infrastructure, IT infrastructure, yes, that's possible today with your cloud. That's my real life example. Okay. And also, someone talked about infrastructure as a service, right? So cloud offers different models. One of them is infra as a service. We have software as a service. We have platform as a service. Okay. So I'll come with software as a service. Software as a service is something like this. Your Google, your Gmail, right? Is your Gmail cloud or not? Okay. So to decide whether a service you are using can be called as cloud or not, NSIT, National Standards Institute of the, Institute has NSIT has come up with these 5 characteristics to determine if your service you're using is cloud or not. Okay. For example, on-demand self-service, meaning provision computing resources automatically without requiring interaction with each service provider. So you don't have to talk to anyone if you want to create some computing resources. Okay. That's first part. Meaning if you want to create a server, you don't have to call someone. Okay. Again, one example I give for this use case is, think about 2010, you know, before Uber, Ola are in picture, were in picture. If you have to book a cab, you have to call someone from your phone. Like, let's say someone called as Sky Cabs or Dot Cabs, Meru Cabs. Those were the cab services back then. Okay. So if you have to go to airport, you have to call them and say, hey, I need a cab for tomorrow 11 a.m. Can you send me one? This is my address. And the usual response you would get is, tomorrow we are very, very busy. Sorry, we can't arrange. Either we can have it 8 a.m. in the morning or 12 p.m. 12 noon. So your requirement is 11 a.m. But since they are at the time we did not have so much of Ola and Uber, people used to get these kind of responses. Then cut back to current time. Now, if you want to book a cab, you don't have to talk to anyone, right? So you open your Ola or Uber and select your destination. You'll see cabs, right? So that is without requiring human interaction, right? So similarly, cloud also, earlier if you have to book, you have to write some email to someone and say, okay, how can I reserve some storage? How can I reserve some servers? Now you just log into a server, you just create your, log into a portal like Azure portal or AWS portal and start creating your own resources. And broad network access. So the ability to access your services should be there from multiple, you know, mechanisms: laptop, desktops, software, everything. Okay. Resource pooling, again I'll take the example of Ola, Uber. I mean, I'm not saying Ola and Uber are cloud examples, but what I mean is, uh, when you when you rent Ola, let's say a vehicle number TS095959 is coming to your doorstep from 11 a.m. to 11 a.m. to, let's say, 12 noon, you are using it, then it is your car. But once you once your trip is completed, you're coming out, it will be used by someone else. Okay. But before 11 a.m. it might be used by someone else, so you don't have to know who is using that car. And also, when you're trying to book the cab, you don't know from where the cab is coming or who has used it before that, right? So that means Ola and Uber have these hundreds of drivers or hundreds of car owners who registered with them. They will randomly pick something. Similarly, in AWS or Azure, you will have hundreds of servers which are hosted on, uh, you know, their cloud. You just need to select what capacity you need, and you will get a, uh, what do you call, a resource. Rapid elasticity. Again, like I said, elasticity is the ability to increase or decrease your resources. Okay, so that is also one of the characteristics of cloud. And measured service. Measured service is where um, everything is given. I mean, it will show you how much you're using and how much you're paying for the time you're using. Okay, that is the measured service. These are the five essential characteristics of cloud computing. Okay, and again, based on the type of service offered, we have three services: infra as a service, platform as a service, software as a service. Okay, so for you, Gmail might not look like cloud, but it is kind of a cloud. It is software as a service. Or for instance, GoToMeeting, right? The GoToMeeting that we are using today is actually an example of software as a service. In software as a service, you are not developing any application code. You are not writing, you're not building your own servers, or you're not deploying your code on servers. GoToMeeting has already set up everything for me. All I need to do is go to their website, register myself, and based on, whether I want to use a free subscription or a paid subscription, I'll take a subscription, all right, and I will start using it. So software is maintained by who? Who is maintaining the software for GoToMeeting here? The application that we are using?
Service provider.
Yeah, GoTo itself is doing that. And who is running the servers? GoTo itself is running. So all that we are doing is some, access controls. Who can access this meeting link, or who should access this meeting link, and any other settings, we do that. That is software as a service. Like Gmail for business, for example, our own Gmail is also the software as a service, but it's a pre-service. We will not con or GoToMeeting, or let's take the example of WhatsApp business, or any of these things are, I mean, even WhatsApp is a kind of a cloud service. And platform as a service is, let's say you are a developer, you developed a wonderful application using Golang, but you don't want to take the pain of configuring the servers, installing operating system updates, and then running your application on that. You simply need a platform where you can directly run your software without waiting for, without doing all the system updates or whatever it is. So in that case, these cloud providers, Azure, AWS, Oracle, and GCP, all these cloud providers offer you this service where they will say, hey, you just need to tell us where your code is and which language it is written in, whether it is written Python, Java, or Golang, and we will take care of everything underlying it. So that's platform as a service. Infra as a service is you have developed the code, but you also want to run your own servers. In the sense, you want to have control of the operating system, what operating system you want to run, what 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 version of Java you want to run, what version of database you want to run. So you want to take care of your own physical, not the physical infrastructure. You're still not maintaining the physical servers. Physical servers are maintained by AWS. You just need to choose which operating system you need, and which software you want to install. You will do all that installation. Okay, here we will maintain VMs and above. So here, in this case, only code is yours. Everything else is maintained by the cloud provider. In this case, the VMs in the sense virtual machine. Okay, virtual machine is nothing but if it's like a server, but you don't see the physical machine. Okay, plus code plus configuration, everything is maintained by you. Okay, so each of them have their own advantages. You can ask, why can't everyone go for SaaS service? If it is available, of course you'll do that. Okay. So what is the example of large companies using software as a service? Okay. I'm not talking about individuals like you and me, but let's say a company like Citibank or JPMC. Where do they use software as a service? So for their payroll, what is the main job of let's say a large bank like Citibank? Providing financial services. So it builds application around financial services. It builds its all applications and everything around banking application and all. But Citibank also has hundreds of thousands of employees, right? Some lakhs of employees. So for each of these employees, they have to pay their salaries. In India, there might be a different system. In the US, there might be a different system. So they don't want to develop different applications and all these things. So what they do is they will go to some third party site like, let's say, Workday or whatever other websites. Zoho, in India, Zoho is very popular. They say, okay, we need your subscription. We need payroll to be created for 1 lakh users in India. Okay. Um, so yeah, this is how these are the admins who wants to control the payroll, and they will give you access to others. So then these workday or payroll, they will create all the pay slips. I mean, they will give you the required software to create payrolls and update your employees about that thing. Or learning websites. Every company wants their employees to be trained on so many things. Some things could be compliance related trainings, like you have to understand what is data privacy, you have to understand what is workplace harassment, and also they want their employees to be upskilled. Now if you join a large company, they will give you a learning platform like Udemy for business or LinkedIn learning. So this is another case of software as a service. Okay, so the large organizations don't want to build their own learning platform, correct? Instead, they want someone who has already developed that application. They will take a subscription and they give access to everyone in their company, right? Anyone of you have any of these subscriptions like LinkedIn learning or Udemy for business from your organizations? Or earlier there was this thing called as Saba. Okay, anyway, but you will find that, right? These are all software as a service, and large companies also use software as a service, meaning there is an avail or ServiceNow, for example. ServiceNow is a ticketing tool where you can create incidents and everything, service requests. Or Jira, for instance. Jira is an application developed and maintained by a company called as Confluence. So in your organization, you need to use Jira to assign work to different members, right? So in your team, there are developers, there are testing team members, there are DevOps engineers. So each of them have to be assigned some tasks, right? So where do you do that? You don't simply do everything through email. You want to have a tracking mechanism. So there is Jira application. Okay, this application is developed and run by Confluence, the company. Sorry, not Confluence. What is the name of the company? Anyone? Atlassian. Confluence is another product actually. So almost all the organizations use Jira or some ServiceNow or both of them. So these are again examples of SaaS. They are already running on ServiceNow software servers. They already the code and everything is maintained by ServiceNow, but you just want to have your own ServiceNow portal for your own users, right? So that's an example of SaaS. Platform as a service, we have many examples like managed databases or Kubernetes or combinations of that. Infra as a service, it is also very commonly used based on your requirement. So based on what kind of control you have, how much control you have, whether you want to do everything yourself or whether you want to just use the existing service, based on that, you can use a combination of these three things. Okay, today in today's world, every company uses at least some of these SaaS products, right? It's called as SaaS, software as a service, and it runs its own business. So definitely it has its own PaaS components and IaaS components. PaaS means platform as a service, right? So every company uses combination of these things. Even if they are not on fully cloud, at least some part of them will have it on cloud. Okay, every company I know uses at least one SaaS product. So even if they say, be it Citibank, be it JPMC, be it, I mean, every organization is eventually moving to cloud, but everyone is already using some sort of cloud service like SaaS. Okay. Anyway, any questions on this? Okay. I went more than expected. Let's move on a little faster. Okay, if you don't have any questions. So these are the characteristics of cloud computing. And what is Microsoft Azure, right? So Azure is one of the three top cloud providers. When I say three, we're talking about AWS, Azure, and Google Cloud Platform, right? So um, AWS was the, I mean, even before AWS, there were other cloud providers like, Heroku and all that stuff. But AWS has come with a very dynamic and very you know a refreshed version of cloud. So everyone started using AWS because it started in 2006. Microsoft Azure has started in 2010, but it had some initial hiccups. It had its own problems, and eventually it moved to, it started picking up pace from 2015, but today it's one of the very fastest growing cloud provider. Google is left behind Microsoft Azure in terms of catching up. Okay, AWS is still the leader, I guess, but Microsoft Azure is also coming very close. All right. So Microsoft Azure is nothing but a cloud provider. Cloud provider in the sense they maintain data centers at different locations all across India. Okay, we have Microsoft Azure locations in Delhi, and I'm not sure about Hyderabad, but somewhere in South India. Um, so if you want to run your website for people in India, you can choose the location from Azure portal and create a server in India in one of the data centers which is run by Microsoft, and you can deploy your code there, and your end users will access that. Okay, so it has its, or you want to create an application for people in the US, you can sit from India and create an application, or provision servers and everything in the US also. So you can access servers across the globe. Okay, so it's a cloud provider. Cloud provider offers all those things that we talked about. Okay, within Microsoft Azure, you have IaaS components like VMs and all this stuff. You also have PaaS components like managed databases, managed or web applications, everything which Microsoft manages. Only you need to upload your code. Okay, so that's Microsoft Azure. So any questions on what cloud is, or how is it important to businesses? So today, one thing I would like to add is, not only the complete commercial, or what do you call, online businesses like Flipkart or Amazon, even those traditional businesses, let's say your power distribution company. Okay, I'm talking about companies like TSS PDCL, public sector companies, or APSDCL. All these things also need their own software, their own websites, their own applications, right? Or public sector banks, your automobile industry, right? Automobile industry also or your traditional apparel makers like Adidas. Everyone needs IT today, right? For their internal management and for their external marketing and everything also. So um, everyone is going digital, and there's a need for infrastructure, and these cloud providers are coming into that picture. Instead of everyone building their own infrastructure, they can use infrastructure from AWS or Azure. Okay, any questions? Anything that is not clear or you want me to elaborate before we go into next step, which is DevOps?
No, it's all clear.
All right, thank you. Um, all right, so moving on. So this is another buzzword we have been hearing from the last 5 6 years predominantly. Okay, it's been there even before that, but everyone started talking about DevOps from the last 4 5 years. So what is DevOps? So I will give you a brief history without going into much details. All right. So there were traditionally three kinds of roles in IT development. Okay, what are those, right? So you have people who write the actual code, right? People who write the actual code on their own laptops, dev, developer. Okay,
Yeah, sorry for interrupt you.
Mhm.
Kiran. Yeah, I think regular section will start better to tomorrow.
Yeah, but I just want to give you an overview before we'll go there. Yeah, if you have to drop off, that's fine. I think this is also recorded. You'll get the session. Okay. So yeah, I'll take a few more minutes and explain what DevOps is, why is it important. Then, I'll take the questions. So then we have operations teams. So people who used to maintain the servers, who used to take the code developed by developers and put it in the servers and maintain all the other things that are required, like monitoring. Monitoring is whether your servers are running, whether they are giving the required response to the end users or not. All this is monitoring. And also there is another set of people. What is that role called as? So you write code and it is going into your production systems, but before that they have to check if everything is working as expected. What is the team known as?
Testing.
Development team. Testing. Fantastic. Or we call it as QA, quality assurance. QA, QC, whatever you call it. QA, okay? SQA, software quality assurance. So these are the people who ensure that before the application is running in production, it is working as expected in the lower environments. Okay. So these are the three traditional roles. So over a period of time, how it used to work is, okay, for the sake of our, you know, for the sake of our understanding, we'll take dev and QA as one team. Okay, because they work in close proximity. So, wait a second. Let me, yeah, right. This is one team. What's wrong? Anyway, yeah, and this is another team. So, before this concept of DevOps, developers used to develop some code over a number of years or number of days, and suddenly QA will test, but ops team don't know anything about the new application that is being developed. They only know about the current application, they're maintaining it. So one day, let's say this new application has to go live or has to become publicly available in, let's say, 10 days. Then this team will say, or project manager or whoever is there, and says, hey, ops team, we are launching a new service and we need so many servers. This is it is going to run on, let's say, Java 18. We need MySQL servers for this. We need front end as Nginx, whatever configuration requirements. He gives everything. Okay, again, if none of the terms make sense, that's fine. So they will give you the tech stack, basically what is the application made of and where they want to run this. So then ops team has to run helter skelter. Now they have to understand, wow, I need to create 10 servers. I have to you know update Java in also, or install Java in all of these systems and all that stuff. Okay, so they will give the code here and send it to ops. But again, there might be some issues when they tested in their lower environment. When I say lower environment, before you run your application for public, you test it inside yours. So you need own servers. So in QA environment, let's say everything is working fine when QA tested. The same thing they are putting in production, it's failing, it's not working. It is giving some database related errors or whatever. So then you go back to the dev and says, hey, it's not working. And the dev says, hey, it works on my machine. It's your problem. You fix it. So then ops team figures out what is the difference between his own machine or the QA environment and what is in the production environment, and he will fix it. So this was delaying software development lifecycle. So there is a concept called a software development lifecycle. Again, I'll discuss this in detail. So what that is, you have plan at a very high level. It is plan, build, implement, test, and monitor, or test and implement rather, right? So meaning you first plan whatever you need, then you build the actual application, write the code and all that, then you test it, then you implement or make it live, then you continuously monitor it. So earlier, up till the test part, ops teams would not have any idea what is happening behind the screens. So they have to continuously, and then just few days before the actual go live, before the application is being released to the public, they will come to know and they have to do all the stuff. And again, these problems would come back and forth. Oh no, I don't know how this should run here and all that stuff. So now with the principle of DevOps, what it mainly underlines is that all these teams should work together from day zero. Okay? from the first day of the development or first day of the planning itself, not even development, even in the build plan phase itself, ops teams should also be involved. Okay, and not only that, that's the cultural aspect. So you have to work together as one team. That's one part. And also there is another thing, that you need to ensure your software delivery velocity, meaning the number of new features you're releasing to the customers is increasing. So what is features, right? So again, a small example. If you look at WhatsApp today, WhatsApp today has a lot of features. What are some of the features? Like voice messages, okay, GIFs, responses, reactions, not responses, sorry, statuses, video calling, group video calling, businesses, and everything. But if you are old like me, if you remember the first time WhatsApp has come, it is simply simple like an SMS, except that it is on internet. It's not depending upon your telephone provider, so it's running through Wi-Fi. So it's like a very simple text messaging tool. Then they started introducing images. Then they introduced group chats. Then they introduced voice messages. Then they introduced video and phone, everything. So when WhatsApp launched, it has very minimal features. Over a period of time, they started adding new features, and they're still adding more features. And also, whenever you introduce a new feature, there might be a bug also. Bug is nothing but an issue, so that issues have to be fixed from time to time. Okay, so you need to add new features, and also fix the coming up bugs. So if you develop an application, it's not like done and dusted. It's not like now Meta is not doing any development. WhatsApp is being continuously updated. They're adding new features, they're fixing the security vulnerabilities. Okay, and in the meanwhile, they also added this encryption feature. What they said was, whatever you're typing here can be seen only by the other person who you want to send. Anyone anyone else, including your ISP or anyone, cannot read your messages because it's encrypted. Only you and the receiver can see the messages. That's another security feature they implemented, right? So all these features keep on building over the period of time. so so is the case with your banking application. Maybe you have UPI, but you think they're not working on developing the new features. They are continuously developing the new features. So every application has the new features rollout and bug fixing and maintenance and all these things. So you have to consistently work on an application, make changes, and bring it to public. But before you bring it to the public, you make sure it's properly tested. Okay, it goes through your security scannings and everything and released to the public. So that is what is a software development velocity, the number of features you can release, to the users. Earlier, these features used to come once in a few weeks, once in a few months. Now, if you can see, most of your Android applications receives updates on daily basis or weekly basis, right? That means the dev teams are working in the background and building it, the QA is testing it, and the ops team is releasing it. But to ensure you get more features, because if you don't release more features, what happens? Competition will take over you. If WhatsApp did not update so many features today, we all would be using something like Signal or Telegram or WeChat, whatever it is, right? So the number of features you release, and also release with the good quality, you have to make sure they're not breaking the existing functionality. Okay, so main aim of DevOps is to have that speed, agility, right? Agile, it's closely aligned with agile. So DevOps is a set of software development practices that combine software development and information technology operations to shorten the systems development lifecycle. Notice this line: shorten the systems development lifecycle or software development lifecycle. Meaning, from the plan stage to delivery stage, it should be short. Meaning, you're releasing today your users come with a requirement for a feature. Okay, for example, let's say phone pay app. All the merchants say that, okay, for the failed transaction, we want to get a ETA when our amount is going to get back. Okay, when we are going to get the returns. So that's a new feature they're asking. So that is, then you plan the feature, then you build it, then you test it. So it has to be launched quickly. If not, let's say phone pay launches the same feature, you're losing the business, right? And see, underlining points is shorten the software development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. As per your business requirements, you have to do all these things, not delivering any features. Okay, so what does a DevOps person do? What does a DevOps engineer do, right? So DevOps in theory is all about all these things combined: people plus practices plus tools. Practices means something I talked about, right? So earlier these teams used to be separate. Now they work as a single unit. They participate in the daily stand-up. They have a common book of work called as backlog items and everything. Okay, that's a cultural shift. Plus you need tools. So if you want to automate everything, it's not simply that you say, oh, we will all sit together as a team and everything becomes better. No, right? You have to give the developers the tools through which they can test their code faster, they can iterate faster and send it to the public, right? So DevOps aims to create better coordination between development, QA, and operations, and speed up software releases with utmost quality. Quality is also very important. So the primary aim of adopting DevOps culture is to build and release software quickly and maintain applications with high availability and resilience. Okay, you have built a wonderful app. All the features are wonderful, but what happens every now and then? Your app crashes or it is going offline. Then what is the point? So that's what I mean by high availability. High availability means you should never notice any downtime. I mean, there might be downtime. WhatsApp goes down once in a while. Even Netflix goes down once in a while, but still you will not notice very often, right? And resilience is, even if it goes down, it has to come back online very soon. Okay. You all might have experienced some WhatsApp issues, right? And everyone then goes to Twitter. Hey, what is happening with WhatsApp? Or if Twitter is down, everyone goes to, let's say, something like Facebook and say, hey, what's happening with Twitter? But they will come back very soon, right? That's the resilience part. So all these things are DevOps. But what does a DevOps engineer do? He is the one who owns and manages IT infrastructure. Owns in the sense not buying them, but he is responsible for managing the IT infrastructure for an application or a set of application. Depending upon which organization you are working, you might be working for only one application, or you might have to manage more than one application. Okay, so each application runs on some set of software, whether it is on cloud or on premise, doesn't matter. And not only that, you have to create and maintain tooling for all these things: infrastructure provisioning, configuration management, application deployment, and also monitoring. Okay, so what is application deployment? After the QA has tested everything, it has to be deployed in your servers. Even before QA tests, it has to be deployed in your dev environment. All these things you will take care of it. Okay, and primarily automate, automate, and automate. Everything should be automated. Let's say your team says they need 10 servers to install their new application. So you shouldn't sit in front of the Azure portal. Maybe you're using cloud. You shouldn't sit in front of Azure portal and click, 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 and create 10 servers. You need to have some automation which will create these things with minimal effort. You just need to, click on one button and it should create your infrastructure, right? So that's what a DevOps engineer do. And again, these things differ from company to company. Some companies might ask you to do everything. Some companies might ask you to only to do application deployment or CI/CD. You might have heard of this term called as CI/CD, continuous integration and continuous delivery. So that's what I mean by application deployment in plain terms. Or some portions you might be only responsible for infrastructure provisioning. Okay, so there is still a lot of evolution going on. Evolution in the meaning, evolution in the sense that things are still not finally clear what a DevOps engineer do, right? But you will do some or all of these things at a very broad level, from infrastructure maintenance, from monitoring, the configuration management, application deployment. Of course, configuration management includes many other things like operating system updates and everything. Okay, so that's a DevOps engineer's bread and butter, if you ask me. Okay, any questions? So again, at the broad level, there is a set of people who develop code, who are the developers. They write the code. We have to ensure whatever they are developing is properly tested. We don't do the testing. DevOps engineers don't do the testing, but they have to coordinate all these aspects, right? Yeah, any questions?
So if a person don't have any coding knowledge, means do we sufficient to understand this course, or do we need any basic coding skills?
Yes, I will come to that. Okay.
Yeah, okay.
Okay, so at a very high level, these are the very high level. Okay, I still put Jenkins, but again outdated. We're going to talk about GitHub Actions. Okay, why did I not change it? Again, there is a very important reason for moving from Jenkins. In the earlier classes, I used to teach Jenkins and also Azure DevOps, but now I'm primarily teaching GitHub Actions because GitHub Actions is in demand. Okay, uh, but I will give you, as per the availability time slots, or maybe a recorded session of what is Jenkins and how it works. Okay, uh, but we'll focus on GitHub Actions. Okay, because GitHub Actions is again a cloud provider. So we're going to learn, because anything that needs to run has to have an operating system. Today, I'm running my laptop on Linux, and you're running maybe your laptop on um, maybe Windows, right? Similarly, if you have to install an application, you need to install it on a server which has some kind of operating system. But there is also one meme. Uh, a kid asks her mother, "Mommy, what is cloud? What are clouds made of?" She says clouds are made of mostly Linux servers, because in today's world everything is running on Linux. Okay, including your smart TVs, your smartphones, everything is running on Linux. Okay, so we'll understand Linux in a deep dive. Then the cloud we are going to learn is obviously Azure. That's the course name also. Version control. How do developers save their code? Okay, that is using Git. Infrastructure as a code. So how do we create servers automatically without going to the portal and doing the manual work? Terraform. Continuous integration and continuous delivery. How do we take the code that developers developed and put it in the production servers using GitHub Actions? Okay, and today everyone is talking about Docker and Kubernetes. These are like very hot topics and still getting stronger. There are not enough engineers who are well versed with Docker and Kubernetes. So this is in demand. We are going to focus on those things. And from the monitoring perspective, we'll talk about how Azure Monitor works, because obviously we are dealing with cloud. Maybe I'll give you a understanding about what monitoring is at a very high level. Okay, and also we'll talk about other tools like Prometheus. Okay, again, this is a very high level view. You can I will send a document to career IT folks. They will send it to you with a detailed description of each of what are we learning. Okay, for example, in Linux we are going to talk about how do you access a Linux server, how do you open a file, how do you how do you install software, how do you start a service. Everything we'll talk in Linux. In Azure, we talk from basics like how to create your Azure subscription. Okay, uh, how to create VMs, how to create SQL servers, how to create everything, and all these things again we'll do it through automation using Terraform. All right, and also Docker. How do we install Docker on Windows or Linux, and how do we create our own Docker files, and how do we run them on Kubernetes? All these things I'll show you. Okay, I'll show it to you. Okay, so these are all very we will go into deep in each of these topics. I put only these things because at a very high level you can tell your anyone, if you what are you going to learn. You can say you're learning Terraform, GitHub Actions, Docker, Kubernetes, and Azure Monitor. Okay, so GitHub Actions is very much equivalent to Jenkins, but it has more features. Coming back to the very important question of whether you need development skills or not, right? Okay, my one word answer is this: don't be, in all caps, in purpose I'm writing in all caps, I'm not shouting at you, don't be afraid of code. Okay, so there are two parts. There is software development, there is programming, hardcore programming, systems programming. Okay, software development, and then there is coding or scripting as they call it. Okay, so we're going to do the third part. Programming is again very research level, very high level thing. Software development, coding is done by developers. So we are going to talk about scripting. So think of this thing. We are going to use a lot of keyboard than mouse. Okay, meaning not much of graphical user interface, but more of terminal. We are going to use command lines. Okay, but that doesn't mean we are developing any code from the beginning. We just take the code that is already available, and repurpose it or make it suitable for our own convenience. For example, Terraform, or oh, even before Terraform, Linux. eh, all commands, not coding commands. And Linux shell scripting, we learn shell scripting as well, how to automate some scripts, some tasks. Okay, you need not do all the tasks again and again. Hello, can you all hear me?
Yeah, sorry for interrupting you.
Yeah, yeah.
You put on the
Hello,
CI/CD pipeline, right? Hello, hello.
hello.
Am I audible?
Yes, yes. Sorry, I think I muted myself. But were you able to follow?
Yes.
Okay, so Linux commands and shell scripting, all this is writing code, but it's not programming. You're not developing anything from scratch. All right. Then we have Terraform. Again, this is a way to automate how to create resources on Azure, for example, Azure or AWS anywhere, but we are learning on Azure. So here you write some code. You take the code that is existing in Terraform documentation, you put it in your own notepad or wherever you want to write the notepad, and you're going to format it, make some changes. Okay, it's not development. It's not. It's some kind of scripting. Okay, you learn Kubernetes. As part of Kubernetes, you create some YAML files. YAML is a language, but not a programming language. You have Docker, you develop Docker files. It is code, but not again programming. You just need to understand the syntax, where to put which. Okay, what this line means. Okay, it's not programming, it's simple scripting. Okay, so don't be afraid of code. See, if you want to have a good career, I can say that, okay, these are all just simple things, just by heart it, and explain it in the interviews. But I don't want to say that. Okay, we should be strong enough to understand, you know, the code that we are developing as DevOps tools. Okay, this is not really difficult, very simple. Okay, we don't develop anything like a we don't have to know Java, we don't have to know Python. If you know Python, and if you know some of these tools, primarily any of these tools including a cloud, you're a hot cake. Okay, but I myself don't know very much about cloud, sorry, Python, not cloud. What I mean is I don't know much about Python. I have done some automation through Python, but my strength is in these things: Kubernetes, Docker, Terraform, cloud. Okay, I talk about these things, Linux, but I'm not afraid of code. You should not be afraid of code. Okay, so
Okay.
there is something else I'm going to tell in the next page, which might panic you or give you some comfort, but it's not much difficult. We just need to focus on what is there, look at the existing documentation, and make changes to our code as per it. Okay, so I'm going to go from scratch, so you don't have to worry. But are we going to do coding? Yes, we are going to do coding. Okay, call it coding or scripting, but it's not software development. We are not writing web applications using Java or Python or anything like that. All right.
Okay. Okay.
Now, any
Thank you.
questions? Yeah. So yeah, please don't be afraid of code. Okay. Not every. See, for example, we are also going to learn Git, right? Git, for instance, you can do it directly from using tools like VS Code without running knowing any commands. But I want you to understand the commands before you use it in a graphical user interface. Okay, so we will understand how Git works, how GitHub works, everything. Okay,
Yeah.
Okay.
Hello.
yeah, go on.
Yeah. There is a CI/CD pipeline. You should teach us both classic and YAML, or only
Okay,
classic.
see, in GitHub Actions there is no classic. Okay, but see, that's why I'm telling, right? We are, if
Yeah.
you want to learn Jenkins, yes, I can teach you Jenkins. It makes my life much easier. Okay, you want to talk about Azure DevOps and only talk about classic pipelines, I can talk about it. But that you can learn from any YouTube video today. Okay, but what I want is to work on is the latest technology that is in demand in the market. Okay, do this exercise. Okay, go to any LinkedIn or Indeed, search for DevOps profiles, look at some of the job descriptions. Okay, you will find most of these things. Okay, yeah, monitoring, in monitoring things, I did not add many things to confuse you, like Prometheus and other stuff. We are going to discuss those things as well. Okay, but these are like bare minimum. One cloud provider, here we are learning Azure, and it's very picking up very fast. The requirement is also high. Linux, of course, it's a bare minimum. You need to know Linux. There's no other way for a DevOps engineer. Okay, there is no Windows in our course. Okay, we are not going to talk how to run PowerShell commands and all that stuff. Only Linux, because that's in demand and that's always will be in demand. And version control. I mean, are there no Windows servers today? Yes, but there are very less and they are also decreasing. Even Microsoft is investing a lot in Linux. Okay, when I say Linux, um, there was once they when they said Linux is bad, that but today they say that we love Linux. Anyway, um, so yeah, and Git is like very basic essentials for every DevOps engineer, because you're going to work on CI/CD. Without understanding Git, how can you work on CI/CD, right? And as I said, Docker and Kubernetes. I mean, people might not even mention Docker today, because if you know Kubernetes, that means you should know Docker, right? But people will ask these questions in interviews. So Kubernetes is one of the, again, very emerging technology. Not emerging. It's almost like mature today, but very in demand. All right. So that's the very high level course curriculum. There is a Word document also I sent across. I'll ask that to be sent to you also. Okay, so what are the bonuses you're going to get apart from the course curriculum? Okay, again, like I told you, each of these topics has at least, this one has at least 5 6 subsections. Azure has at least 10 subsections. Terraform has 3 subsections. I'm not going to talk about all this here, but we are going to go from basics to intermediate level, sometimes expert level also. So you will get interview tips. I don't like to give all the interview tips towards the end of the course, but after each topic, I would like to talk about what could be the possible interview questions. But I have a bad habit. I don't have a notes of interview, and I also don't encourage you to read these interview questions for DevOps engineers and all that. No, the interviews have changed today, folks. No one is going to ask you from a set of interview questions. If anyone is asking like that, that means that team is really messed up. No one should ask you from a set of questions. It should They should look at your resume. You say you have worked on Kubernetes, then they will ask questions. They should ask questions. Ideally, they ask questions from that point of view, from your what you mentioned in your project. Okay, and I'll give you notes and cheat sheets for all the topics, including Linux and Azure and Terraform, everything. I'll give you how did we do that in the class for your ready reckoning. You can look at them. Resume tips, obviously. You can also send me your resumes and I can review them. How to write a good resume and all that. Yeah, this thing I said, something that could make you happy or panic. My numbering is totally off. 1 2 2 3, whatever. Okay, Chat GPT. You heard of this? I think everyone might have heard of it. There is no way you might not have heard about it unless you're living under a rock, because everyone is talking about it. I don't claim to be a expert in what ChatGPT does, but I can tell you 1 or 2 tips on how is it useful for a DevOps engineer. Okay, how can we use it in our real life? Okay, so I'll give you an example, quick example. I know I'm going fast, but yeah. So recently I applied for a company. They gave me a task. Some companies gives you tasks before they do the second round of interview. Okay, so they asked me to do something on Kubernetes with GitHub Actions, but I also need to develop my own application running on Node. Node is another Node.js. Node.js is another application programming language, you could say, JavaScript. Uh, so they asked me to develop this application. It's a very basic application, like Hello World application. They said we don't care what it is, but I still don't want to spend my time and learning what Node is, how are modules and everything. I simply went to ChatGPT, asked, gave the requirement in the chat. You know, how ChatGPT works. You enter your question, it gives the answer. So I entered my question like, develop a Node application which will simply redirect me to another application, another website. That's all. And it gave me the entire code. All that I need to do is put it in my repository, test it. I tested it, of course. Okay. So similarly, tomorrow, if you're stuck somewhere, you can go to ChatGPT and ask, hey ChatGPT, I need to write a Linux script to, you know, uh, to delete all the files older than 100 days. It will give you the script. Okay, you have to just take it. But then you might ask, why do we even need all this learning? We can simply go to ChatGPT. No, ChatGPT is not 100% accurate today, and ChatGPT doesn't understand the requirements mostly completely. Okay, you have to still test it. You have to still do your own, tweaking and all that stuff. Anyway, okay, but what I'm trying to do with this is not trying to make you lazy or not trying to make you not learn, but I'm telling you you can save time using ChatGPT. Okay, it's not cheating, because ChatGPT is a new Google. That's it, right? Back in 2000, developers were so happy because they could start using Google search and learn about other things. right? Before that, right, people used to manually refer to their books, physical books, and understand where they are doing wrongs, where they're doing the mistakes. But then Google came. So now we have Chat GPT. So you have to make it a part of your everyday life as a professional, okay, as a DevOps professional. You can use Chat GPT. You can search for, you might be stuck somewhere, or it might be a new topic. The thing with DevOps is it's both wide and deep. Wide means you have to focus on so many areas. Like I said, these are like, you know infrastructure as code, Terraform. But you have to go deep. You have continuous integration and continuous delivery. You have containers and orchestration. You have monitoring, version control. In all of these things, these are so many areas. For example, look at a Java developer, right? He focuses on only Java or maybe some frameworks. But here we go into different streams, and also we have to go in depth into each of these streams, right? So that's where we can make chat gpt useful for us. So I'll give you some tips on how you can use chat gpt, not in the initial days, obviously not in the initial days, not up till the 3 or 4 weeks. Then maybe we can see some real-time examples of how you can integrate chat gpt into your everyday work style, or your practices also. But again, I say use it with caution. Okay, use it, but don't depend solely on chat gpt. All right, so again, what do you need to have to be in this course? Okay, that's my again, yeah, I don't know. I freshly developed it yesterday, this presentation. Okay, so you need to have a computer, obviously. Don't depend upon your smartphones or laptop, tablets, or iPads. You need a computer, and I would request every one of you to join, buy a computer in the classes. Sometimes we might do impromptu tasks. Immediately we might do some tasks, okay, with administrator rights, because you will need to install some software like Git, Azure CLI, Docker, and VS Code. Again, simple installation. I will help you with all those things. And subscriptions. What subscriptions you might require? You might need an Azure. You will need, not you might. You will need an Azure free tier subscription plus a backup account as well. Why backup? Backup means Azure free tier is only for 1 month. After 1 month, you have to upgrade to pay as you go. Pay as you go in the sense you have to pay for the resources you are using. But for the first month, it gives you up to 15,000 INR credits. I mean, it doesn't give you the money, but you can create resources worth 15,000. So in the first month, we can use it extensively to create resources and practice and do everything. But in the second month, what will you do? You want to get a new bill? No. What you will do is you'll ask your brother or your cousin or anyone to create a new account for you and give it to you. One tip, I mean, I'll again talk about this later, but again, don't do it from the same house, same address. Azure can pick up your IP address and it will not allow you to create a second free tier account from the same account. So that's why you have to ask your friends or anyone. Okay, anyway, so that's what you need for this course. You need an Azure free tier account, no money. You just need a debit card, credit card to validate. Unfortunately, Azure requires only credit card. AWS will take debit card also, but for Azure free tier, you need a credit card. It will not be billed. You will not be billed anything, but for identification, you would need a credit card. Okay, so that's one thing. Don't worry, you should be able to get it somehow. And then GitHub, again, free subscription. You have to create a subscription. You have to create an account for yourself in GitHub. And Docker Hub, for containers, that's also a free account. You can create it. Okay, again, like I said, the software you need is Git, Azure CLI, Docker, and VS Code. VS Code is nothing but Visual Studio Code, which is a code editor. When you write code, it will help you in the formatting. It will help you correct your mistakes. Okay, so that's VS Code. Instead of writing in Notepad, see, all code is nothing but text, letters and symbols. All code is letters, numbers, and symbols. But you can write the same code in Notepad or anywhere, but writing in VS Code helps you in proper formatting. It will help you to understand the syntax and everything. These are from a technical perspective. From a personal perspective, what are the requirements? You don't need any coding knowledge, like I said. You don't need anything. We are going to learn coding, but you don't need any previous knowledge. If you have it, wonderful. If you have worked in Linux, awesome. If you have worked in a development team, wonderful. That will be a plus. Okay, it's not going to be a negative, it's going to be definitely a plus. But if you don't have them also, there's no problem. But you're going to start learning, and the only way you can learn better is active participation in the sessions. Listen to the sessions, ask me questions, and quality time for daily practice. Folks, I'm telling you, I've been in this industry for, I mean, in the IT industry for 13 months, 13 years, I'm sorry. But let's say my DevOps career began somewhere around 2014. the core DevOps. Even before also we used to do the same things, but the automation and the agile methodology and everything came from 2014, at least in my experience, 2013, 2014, I would say. These 8 years, I still have to practice sometimes, okay, or learn something new. It's a continuous thing, okay. So yeah. So someone asked me in an interview, like, what is the most why do you like being a DevOps engineer? The reason being is there is a lot to learn, continuously improve yourself. And also that is the reason also I hate DevOps, because there is always something new to learn. You're always on the uh, you know tenter hooks. You always have to learn and upgrade. But that's true for any stream today, right? In any stream today, you have to learn all these things. Developers are learning Kubernetes and Docker and everything because they also want to stay updated, right? So the classes might be for 1 hour 15 minutes to 1 hour 20 minutes, sometimes 1 hour 30 minutes also. Besides that, I don't know how you want to schedule your day, but you need to have quality time for daily practice, right? Practice whatever we are teaching in the class. See, I give a simple dumb example to everyone. So let's say you're in an interview and the interviewer asks what is 2 plus 2, right? And you say 4, and the interviewer looks straight into your eyes with a very serious face and says, and then gives a smile. It's 5. You don't know this? He might say this. Okay. If you have already done the math sometime in your life, if you have actually put on a pen and a paper and did 2 plus 2 equal to 4, you can immediately say 2 plus 2 equal to 4. I can tell you that. Okay. But if you have never done that math but only listened from someone, then when he laughs with that sarcastic smile, right, you will doubt yourself and you think, maybe I'm wrong. That's where he catches you, right? Similarly, if you practice all these things that we are going to discuss in the class, you gain the confidence. When he asks something about some Git or Docker or whatever it is, you can confidently say no. I mean, if he says that's incorrect, you can say, I'm sure that is how it is, at least in the version so and so. That's how I did it. I don't know if they have an update, but I can tell you in so and so update, this is the feature, this is how I used it. Okay. So you can tell that only if you have actually practiced it. Correct or wrong? I
Yes.
mean, I know the 2 plus 2 example is dumb, but what I want to say is there is a difference in confidence between the person who has actually done 2 plus 2 or someone who has just listened in the class or just heard it from his friends. That's my point. So is the case here. Every day you listen to my class but you never practiced, it might go into your memory, go out of your memory, right? So practicing is the only way you can learn your uh, topics, right? So I'm open for questions.
So,
Any kind of question. Yeah, go on please.
yeah, so a couple of questions. So, first thing
Uh-huh.
is, will there be any chance or purpose of using PowerShell here? Is it prerequisite?
uh No, no, we are not using PowerShell. Like I told you, Windows requirement is there, but very little. But what you can do is from the Linux classes, you can definitely, I mean, Linux and PowerShell have different syntaxes, but you'll get the basic idea, right? You'll get the basic idea, and you should be able to learn PowerShell on your own. But no, we are not covering PowerShell.
Okay.
I'll
Yeah,
tell you, the last
great.
time I used PowerShell was like 2 years ago for one single project. Again. Uh, uh, in a single automation. But yeah, there might be some cases. Sorry, who is this? I don't have
Raghu.
Raghu. Yeah, there might be some cases where the company might be entirely or largely focused on Windows systems. In that case, yes, you will have to learn it. Uh, but again, I haven't encountered. Yeah, there are still many companies which might be using PowerShell at a very large scale, but again, very limited opportunities. Yeah, you should. I mean, if you're interested, yeah, you can definitely understand. Once we talk about scripting and the basic concepts of uh, scripting, you should be able to catch up PowerShell as well. But I hate PowerShell with all my life. Yeah.
Got it. Makes sense. And then you spoke about the practice sessions, right?
Mm. Mhm.
So, how different it will be real-time environment? Of course, scenarios.
Yeah. See, uh, the beauty of cloud and the open source systems today we have is you can almost create the same environment you have it in production environment. Okay, but what changes is the governance, meaning how much of control you have in the systems where you're working in real time. For example, I'm working for a large financial institution, for a client. Okay, uh, here, even if I have to test a simple thing, there are 10 approvals. Okay, that things changes. See, when I create my own Azure subscription and I go there, I can do anything I want. I can delete a server, I can create a server. Maybe when you're working in real time, maybe you have access only to update a few things. Maybe you have to request someone else uh, to create resources for you. Maybe you can have Terraform script, but that has to run through a pipeline and someone has to approve. So here, the governance part varies widely. It depends upon company to company. But apart from that, the kind of work we do might not vary very much. There are few changes here and there, like every company has their own kind of naming conventions. Okay, or the way they want to call their servers, or the way they want to create some resources might vary. But from the scripting and coding perspective, and the way we do stuff, not much different. Yeah, I can tell you that.
Yeah, got it, Kiran. Thank you.
And there are two things, right? There is one team style, there is one personal style. So nothing is same in software industry, right? Not only for DevOps, for anything, each person has its own style. That's all right also. You should not be bothered about. Okay, any other questions?
Hi, this is also.
Yeah,
I
Kaustav.
have one question.
Mhm.
Docker and Kubernetes, you're going to, yeah, you mentioned so many times from scratch.
Mm.
You will focus the same on Docker and Kubernetes also. From scratch
Obviously,
means
yes, yes.
who doesn't
Yeah,
know it? Oh,
yeah, obviously. See,
okay, okay.
that's why there is a particular order in which we learn things. We learn Linux first, because
Hmm.
without Linux, I mean, so many
Hmm.
people ask me about tips on how
Commands.
to learn. Yeah, tips on how to learn Kubernetes. I said, don't start with Kubernetes, start with Linux if you don't know it. Because without Linux, there is no Docker. Okay. Without, I mean,
Hmm.
I will not say Docker, containers. Docker and containers are same,
Okay.
but containers might be outside. I mean, Docker is just one tool. Okay. Anyway, so containers, to learn containers, you need to understand Linux. Okay, at least from the file system, from the way you install applications, how you copy files, and all these things are very important. And we are going to learn some tools also, right? And then once you learn Docker, you understand how to deploy the applications in Kubernetes. But I want to say one thing: since we have this course for 10 or 12 weeks, we cannot, and we are focusing on Azure cloud. I'm not going to create a Kubernetes cluster from the scratch. I will explain all the concepts, but we are going to use AKS, Azure Kubernetes Service, and we will create it. Okay. I will also tell you how you have to create a Kubernetes cluster, how you can create a Kubernetes cluster. There are so many tools. If you're using on-prem, on-prem, right, your own data
Hmm.
center, then you can use many tools to create your own Kubernetes cluster like KubeSpray and everything. But I'm not
Okay.
going to create a cluster in our classes, because we are going to focus on how to deploy our containers on Kubernetes. That's our focus. Okay, but yeah, it is from very basics. Like, we'll understand what is the architecture of Kubernetes. Okay, yeah, Raghu, you can go
Hmm.
next.
Thank you.
Yeah, no problem. Raghu, you have a
Kiran,
question?
in the course content, whatever is there, so are you going
Mm.
to cover everything? Like I see there is an Ansible in it.
Oh, I think I put Ansible because I took it out, because I uh, see what's happening is, uh, if we go into Ansible, it's taking another four sessions, at least four sessions. So what I thought is I would share the Ansible recorded videos to you and some documentation, and maybe I can take some questions. Okay, because Ansible is also one of the much required skills. But uh, I can tell you this thing also: with Docker and Kubernetes dominating, we don't have a lot of scope for Ansible these days. But it's good to know. So
Okay.
what I will do is, once we complete our Terraform, I will share the Ansible videos with you. I will record new videos and share it with the same drive that I mean, you'll get to a Google Drive share where all the recordings are there. In the same drive, I will ask Career IT folks to put the Ansible recording videos, and you can go through them. And if there are any questions, you can ask them. See, my point is deliver quality stuff, right? I can put two or three more topics also, but I want you to learn them very well. So that's why I'm not including Ansible. But yeah, there you will get recording videos and notes also.
Okay. So I
Yeah,
see some other stuff in content, core content like Azure storage and
yeah, that's
Azure
all part of
network.
Azure. Yeah, yeah. See, like I said, right? Azure has uh, 10 other points. Yeah. So all that we have to cover, right? We have to talk about VMs. We have to talk about in VMs again. We have three, four concepts, right? Images, auto scaling, all these things, and we'll talk about Azure storage. We'll talk about Azure SQL, all these things.
Yeah. Okay.
Yeah, Azure is a big concept, guys. That's going to take a lot of time, a lot of sessions.
Yeah.
Yeah. Raghu, you had a question or you just, I see your hand up.
Yeah, sorry, Karan, that was long back raised hand. I'm good from my end.
Okay, no problem, no problem. Yeah. Anyone else? Any questions?
Yeah, I have another question. So
Go on, Venkat.
after completion of this training, can we put some experience? Yeah, how much experience can we put? Plus,
Okay, I will give you a very calculated answer. Okay. I don't want, see, after completion of this course, there might be so many outputs. Okay.
Mhm,
Maybe there is a guy called Kiran who is joining this course. He's joined the course with all enthusiasm. First 15
mhm,
days, he's doing all the tasks. Okay, actively asking questions, actively answering questions in the class. After 15 days, he loses steam. He stops, you know, he stops practicing or he stops attending the sessions. He's attending the sessions, but from his mobile and on the couch, not listening actively, gone.
mhm,
After the course, he's same as where he was initially. Maybe he learned a few topics, few words, but he's not done. Let's say there is another person called as Venkat. He joined the course from the beginning. He's very focused. He's asking the right questions. He's answering all the questions. He's practicing it. Okay. He's reading. Yeah, I mean, reading and practicing, as like I said, right after the class and next day coming with questions. He has confidence now after the course. He has confidence that he can again going back to the high level course content, just a second. So no one can be a hero on all these things, okay? But like I said, Linux bare minimum, okay? We're not even talking about advanced. Intermediate, till intermediate you have to have bare minimum, okay? Azure, at least the basic IAM policies and everything you have to understand. Git also, yes, bare minimum. But in the remaining topics, even in Azure, you might be you might gain expertise in a few of the topics. But let's say you have very good sound understanding and good exposure in Terraform. Maybe you learn Ansible yourself. GitHub Actions, maybe you are a 5 out of 10. In Terraform, maybe you're 8 out of 10. Okay. In Docker and Kubernetes, maybe you're 6 out of 10. So that's a good combination. You can focus your strength and you can write in your resume such a way that you primarily focused on infrastructure as code projects where Terraform is widely used.
mhm,
You might say yes, you worked on Kubernetes. Okay. You
mhm,
can say yes, I worked on GitHub Actions. Okay. Uh, or you could be a very you understand GitHub Actions very well, you have practiced it very well. Terraform, maybe you're a 6 out of 10. GitHub Actions, you're 8 of 10. Yeah, then you can write your resume in such a way which focuses on CI/CD tooling. Okay. Yeah, or let's say on Kubernetes you worked really well and you feel you're 7 out of 10. No one is 8 out of I mean, at least initially Kubernetes is a tough topic. So let's say you feel you're 6.5 or 6 out of 10. That's really good. You can focus your resume in such a way that you write a lot about Kubernetes projects. Okay. So, and also how much experience you want to put in your resume as a DevOps engineer. You want to put it 2 years. Maybe let's say you're a person with 6 years of administration in 6 years of Linux administration. So you can
mhm,
say from the last 3 years you've been working on Azure and also DevOps. then you can pick which areas you can likely uh, highlight in your resume and talk about them a lot. Okay, that's one thing. So it depends upon how well you're grasping this, how well you're practicing it. There is always some reading that you need to do, some practice you need to do. Okay, yeah. uh, so I would say it's very subjective, but yes, you can, based on what your previous experience is. Let's say you're a QA of 4 years, then you can certainly uh, you know have more advantage, because you might already know a bit about uh, you might already know a bit about CI/CD. You might already know something about environments and all that stuff. So there you can confidently put maybe 3 years of DevOps experience out of your 4 years of QA. You can say that you started as a QA, but quickly moved to DevOps within the same organization. Okay,
Okay.
then again highlight your strengths, where you have learned well, where you know it well. But again, like I said, some things are very bare minimum. Some concepts of Azure you have to get good understanding. Some concept Linux also, you have to have very good knowledge on file system, application management, and all that stuff.
Yeah, okay. Let me tell, I am having 10 years experience in IT
Hmm.
industry,
Hmm.
and currently I am Linux shell-script developer.
Sorry,
Uh,
SQL developer you said?
Shell-script developer. Shell
Okay,
scripting.
Linux administrator. Yeah, okay. Yeah, yeah. Hmm.
Yeah, we'll write the
So
script for.
yeah, you have a very good advantage over many others, because you can, whatever Linux shell scripting you did, extend it to other things. Like, you already know how to create scripting. You understand a lot of concepts better than many others. So now you pick up your topics. You want to focus on Docker and Kubernetes, focus on them, highlight them in your resume, and you say you've been working as DevOps from the last 4 years based on your confidence. Or let's say you're working on DevOps from the last 3 years on how you feel. Okay. Yeah. So what I'm going to do also towards the end of the course is I'm going to give you something like a self-assessment sheet where you can put your current skills, and based on that you can write your experience. I mean, it's not any automation tool. It's just like self-evaluation. You evaluate yourself, and maybe you can learn some topics. You can set your deadlines for some topics also.
Yes,
Okay.
sure.
And basically towards the end, what I want to do is, initially we are going to learn all these things one after the other, right? Like we are going to learn Linux separately, then we're going to learn Terraform separately, and Git and all these things. So we will do pipelines in such a way that you put in you put all these into practice in a single pipeline, like a project. Okay, one project is how to build infrastructure automatically with GitHub Actions. Another project would be how to uh, develop an application, not develop, how to build and deploy an application CI/CD using GitHub Actions. Okay, end to end, like, so that will give you more confidence.
Right.
That's the reason also why I took off Ansible, because I want to focus on the CI/CD and Kubernetes part. We will do CI/CD on Kubernetes as well.
Okay.
Yeah. Okay. Any other questions?
So this Dockers and containers both are same or different?
Okay. So this is like this. Is okay. If cabs is like containers, Docker is like
Mhm.
Uber. So today, particularly not only in India, outside India also, when you talk about cab, no one is saying I'll take a cab. They'll say I'll take a Uber. But there might be other cabs as well, very less known.
Mhm.
That's the case with the Docker and containers. Containers are your cabs, meaning it could be it's basically based on Linux. Okay, but Docker has made it so popular, like Uber has done for taxis.
Mhm.
So now today, when we talk about containers, it's almost like Docker. Okay, it's not Dockers, it's Docker. Docker is the name of the company and also name of the software. Okay, yeah. So uh, it has almost become synonymous, but containers, maybe there are other types of containers you can create, like Podman and other things. These are, I mean, these are tools which help you create containers, which help you run containers. Okay, container is again a Linux concept.
Okay.
But
Got
yeah, uh, if you say Docker, it's implied that you're talking about containers.
it. So what about this Ansible?
Sorry.
Ansible.
Yeah, like I said, right? Ansible, I'm going to give you some recorded sessions where I talk about what Ansible is, how to create playbooks. You can practice them after the course or during the course, and you can come back with some
Okay,
questions.
okay.
Maybe I'll show, yeah, maybe I'll
Yeah,
show you some small demo also. That's fine, based on
I
how
mean,
we. Mhm.
my question is like, what is Ansible? Uh,
Okay, right, you're doing shell scripting, right? So tell me one use case where you have to write a shell script recently. What have written a shell script for?
we are transferring files from on-premise to AWS.
Okay, so file transfer, right? So
Yeah.
Ansible is also an automation tool. Okay, it is,
Mhm,
but it is more like a Swiss army knife. It has multiple use cases. It can create infrastructure like Terraform. It can
mhm,
automate your shell scripting in a better way. Let's say, um, let's say you have to create a shell script for transferring files from on-prem to AWS, right? So you write cp minus rf or rsync or
mhm.
rsync. Are you using that or what?
We use this AWS copy command.
AWS CP command, right? Okay, AWS CP command, right? So AWS CP command, and but maybe you have to do better error handling. So AWS has, sorry, Ansible has a lot of modules which will deal with these things. Instead of writing AWS CP, you can use an Ansible module which does the same thing, but it has some additional advantages like what we call it as idempotency, meaning if something is already done, it will not touch that. Okay, or it can scale up, it can scale very well. Okay, so error handling is another thing. It handles errors better than your shell scripting. Okay, you don't have
Mhm,
to write from the beginning. You just have to put in what you need, what is your target, what is your source, and it will take care of the rest of the thing. Okay, so that's Ansible. So Ansible can be used for software configuration management, meaning you're creating 15 servers, and in 5 servers you have to install something like, let's say, Nginx. In another 6 servers you have to install something like, let's say, Java, JDK, whatever version.
mhm,
Okay, and
mhm,
in another 4 servers you have to install MySQL. So the traditional way is to write a shell script, right? So in
mhm,
Ansible you can mention these things in a declarative way in a YAML file, and it
mhm,
will deploy it automatically. Okay, I mean, not automatic, I mean, shell script also does automatically, but let's say within the 4 systems where you need to install Nginx, let's say 2 of them already have Nginx. What will your shell script do in case of a in that scenario? It will try to reinstall even if there is Nginx is already there. But Ansible,
right.
it will check the current state. It will check the current state and sees, okay, and sees something called as desired state. So what you write in an Ansible playbook is what we call as desired state.
Mhm,
So the current state is what is there in your systems. So Ansible tries to manage map your current state with the desired state. Okay, uh,
okay,
so they both will be always in sync. So let's say uh, current state, machine A, no Nginx. Machine B means let's think about a VM, no Nginx. Machine C, yes, Nginx is there. Machine D again, Nginx is not there. So in the desired state, we are saying that all these machines should have Nginx. So Ansible tries to not tries to installs Nginx here, here, and here, but not here because it's already there. If it's the same version, it already doesn't try to reinstall again. Okay,
mhm,
so that you can do it through shell scripting also, but Ansible gives you what we call as idempotency, like I said, and you put everything in a declarative state like a YAML file, simple YAML file, and it will take care of everything. Okay. There are a lot of
mhm,
modules that are already written in Ansible for file copying, for installing applications, for starting services, and also there are conditional steps you can put. I mean, like your if conditions, but in a much easier way. So that's Ansible for you. It's a configuration management tool, but it can be used as infrastructure as code tool as well. It can be used to manage networking devices like routers and everything else. Yeah.
mhm. So Azure DNS concept also we will going to cover.
You mean TFS?
No, DNS.
Yeah, yeah. DNS is very, very important part, right? Yeah, we have to cover that. How do you? We all have to create our own DNS. Yes.
Yeah, that's all from my side.
Yeah, yeah. Thank you. Any other questions? You can ask me any questions. There are no stupid questions about me or the course or about the market. Anything is fine.
Kiran, like I see DevOps security jobs also. So what is the market compared to this DevOps engineer?
Okay. So there is this new term called, not new term, it's been there for some time, DevSecOps, right? You're talking about that, right?
Yes, yes, right.
So that's more about integrating, security into DevOps, right? That's
It is
about
an
how
allowed.
you, sorry. Okay, please go on mute if you're not talking to us. Okay, anyway, yeah. So DevSecOps is like new practice that is coming up, but it primarily focuses on security practices along with the DevOps practices. So nothing much different there. But again, if you're someone who has some extreme, I mean, some very good knowledge on, let's say, networking and firewalls and advanced knowledge in penetration testing and threat detection, then you could call yourself DevSecOps. But again, you will have to focus on some of these topics. Okay, yeah. So I think it's equally split between DevOps and DevSecOps, and DevSecOps is more about how your organizations are going to implement DevOps, right? It's not about how you learn it, how your organizations want to implement it. But
Yeah,
again, yeah, we will cover some security topics throughout our course. Okay, like firewalls and all these things, but
mm,
not very deep. But yeah, it's see, security has become a very 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 important thing, right? You know the number of cyber attacks happening.
yes,
So yeah, even in our personal lives also, folks, I tell everyone that try to implement security practices. Have strong passwords. Don't use your birthdays and your family members' names as passwords. That's easy to crack. Okay, and also enable MFA wherever possible, multi-factor authentication. Right, like Google asks you, are you trying to sign in something like that? You can put MFA for everything these days, for your email as well. So try to have MFA. Try to have strong passwords. Try to change passwords once in a while, like your organizations ask you. So security is like, and also don't fall for fake websites on WhatsApp or wherever. There are different types of scams. Yeah, so we'll talk about some of these things like what is SSL, how you can, how do you use SSL and all that stuff also.
sure. Thank
Okay, then we'll talk from tomorrow. Any other
Tomorrow same
questions?
time. Tomorrow same time.
You will be notified about that. Yeah,
Oh,
yeah. Generally, we used to have demos on Saturday, so that yeah. But I think you'll get to know today itself.
okay, right. Thank you.
All right. If you do not have any other questions, okay. I hope to see you all in our course. You'll have fun and a lot of learning.
Thank you, Kiran.
Thank you, everyone. Have a good Sunday.
You too.